You see, I can assign an IP address here like this, 2000 colon colon 1 slash 64. What it is meaning, it means this 2000 colon this is what it means. All this I can put colon colon, and this leading 0 I can avoid. This is one way of assigning. In this address, 64-bit is network, which is exact half. This is network portion. That's what this means. This is how we write subnet mask. The length of the network bit. Now this is one way of assigning IP address to an interface. The other way is this. I'll say only 2000 and then 64. What I did not say is, I did not say this portion. I only said this portion. You see, there is no interface prefix mentioned. Here I have mentioned 1, but here not mentioned any number. Is that possible? Yes, it is possible. What will be the interface prefix? Here interface prefix is 1. What will be the interface prefix here? I'll ask the router to use the MAC address of this port. I'll ask the router to use the MAC address. See, the MAC addresses are unique. I'm going to tell router 2 this interface, let's say this is F00. I'll ask that interface to take the MAC address and use it as the interface portion. How to tell that? This is the command. When you say EY64, we are asking the router to take the MAC address, which is a unique identifier. MAC address is called as what? Unique identifier, right? They're unique. Take the MAC address. What is the size of MAC address, Ria? What is the size of MAC address? Okay, very good. So we are asking to take the MAC address, which is only 48-bit, and extend it to 64-bit. Because our interface portion is what? It is 64-bit. Interface ID is 64-bit. So extended unique identifier means what? MAC address is extended to 64-bit and used as the interface portion of the address. So that's another way of assigning IP address. Did you understand what I said? Okay. So what we will do is on this router, we will have another method also. First method, we give the complete IP address. Second method, we give the network portion. The third method we will do on this interface, let's say F0/1. On F0/1 of router 2, we will say auto configure. Auto configure, meaning we will not give any IP address. We will not give anything. It needs to configure an address, complete 128-bit address, complete 128-bit address automatically. Then you may be thinking that he's talking about DHCP. No, this is totally new. This is not DHCP. This is totally new, called auto address configuration. Okay, auto address configuration. How does that work? How it works? Let us say we have an address. For you to easily identify, I'm going to put this address, D A D colon 3/64. Is DAD a hexadecimal number? Of course it is. Of course it is DAD. I can use. Now, if this needs an address, it should be also having that same DAD. Only then they can talk. See here, 2000, here also 2000. Similarly, if router 2 F01 needs to auto configure, it cannot configure some address. It should configure matching with router 3. It should be matching with router 3. Yeah, if router 3 is in DAD network, router 2 F01 also should be in DAD network. Then when you say auto configure, how router 2 knows? How router 2 knows that I need to form an address using DAD in the beginning? How router 2 knows? இன்னொருத்தர் சத்தத்தை காணுமே. வேலைதான் இருக்கிறீங்களா? சரி, இப்போ இதெல்லாத்தையும் நம்ம செஞ்சு பார்க்க போறோம். பேக்கெட் ட்ரேசர்ல எடுத்துக்கலாம். சரி, as we spoke, this is going to have 2000 colon 1/64. We give the complete IP address. Whereas on this side, 2000 colon colon slash 64 EUI 64. This is what we're going to configure on the other side, other routers G00 side. And I say so, as we already planned on G001, we will not be configuring any address. We'll ask it to get configured auto. And on router C, it's going to be BEEF colon colon 3 slash 64. So that will be the address here. And what we are expecting is router B's G001 address to start with BEEF. BEEF. The interface portion will be made out of MAC address, same like EUI64. But the first portion, first hex date should be BEEF only. Let's see how it happens. We'll start from RA. Interface G000, no shut. You see, if you know IPv4, IPv6 is also same. Only difference is wherever you put IP, you have to put IPv6 now. So I'm going to say IPv6 address. We used to say what earlier? IP space address. Now I'm saying IPv6 space address. 2000 colon colon 1 slash 64. Now, what address it is? Is it a link local address or global unicast address? Exactly. As soon as I hit enter, a link local address will be automatically generated. And link local address will start with what? FE80. The remaining portion will be EUI64, the MAC address. Let's see that. I hit enter. See, I did not configure any address beginning with FE80. I did not. But when you go and check, what is the command to verify the interface? Show IP interface brief. But here in IPv6, show IPv6 interface brief. Yeah, it's not much difference, wherever you used to put IP, you're going to put IPv6. Now you can see here the address that we configured as well as the link local address. There. And what is this? This is made out of MAC address, EUI64. Okay. Now we understood one thing, that link local address we no need to configure. And we also know that link local address are used for neighbor discovery. It's used for neighbor discovery. Now let me go to router B. On router B, interface G000 IPv6 address 2000 :/64 EUI64. See, I did not give the interface portion, but when you go and verify, show IPv6 interface brief, you can see the interface portion made out of MAC address. Now, if you want to ping from here, router A, you can ping now, and for your surprise, not even a single packet will be lost. How is that possible? Because of link local address. They already discovered. Understand very well here. In IPv4, only when you ping, ARP will start working and it will learn the MAC address. By the time you lose 1 or 2 packets when you ping for the first time. But in IPv6, even before you ping, they already found a neighbor. They found a neighbor. They use link local address, ICMP version 6 to discover neighbor. Okay, so that's why you don't even lose even single packet. Now what is next? As we already discussed, router B is G001. We won't be giving IP address. Interface G001. I don't want to give IP address. I want to configure auto. IPv6 address auto. I did not give any address. Now, when you do that, a link local address alone will come. A link local address alone has come, using which it can even discover RCs, link local as well as the beef that we are going to put in RC. I'll finish configuring RC and then I'll bring you back and show you here an address starting with beef. I'll go to router C. Interface G0, no shit, IPv6 address beef ::3/64. I have given the complete IP address and I'm expecting an address beginning with beef on router 3 is G001. Let's go and see that. Will it come? No. Still it won't come. I'll show you. Still it has not yet come. Why does not it come? Let me do a debug. Debug IPv6. Debug IPv6 neighbor discovery. That's one thing. But I also want to debug IPv6. Oh, you don't have any other command. No problem. So the reason why I'm not getting is we have to enable routing feature for IPv6. I'll go to router C and say now config C. This is the command IPv6 unicast routing. Understand this. If you don't put this command, this is not an IPv6 router. This command only makes this router to be capable of an IPv6 routing device. By default, only IPv4 is enabled. Even though it was showing you the IP addresses, even it will show you the routing table. See, even before typing this, show IPv6 route, it shows the routing table. But it won't allow the packet to pass through. No routing is permitted for IPv6. Not only that, the neighbor service station, meaning it won't go and tell me that I'm going to use this address. Is there anyone to object it? It won't check for duplicate address detection. It won't detect. See, router B did not receive any. So far, router B did not receive any packet. I have enabled debug. It did not receive any packet so far from router C. Now I'll go to router C and put this command IPv6. As soon as I hit enter, you will see a lot of drama. Okay, I hit enter. Now you see the drama will start. Router B, show me the drama. Here it started. It's called a route advertisement using ICMP version 6 is received on G001. So router C is telling I'm using this link local address. Actually, there are many other debug commands, but packages don't support. Okay. Now, according to me, by now it would have learned the beef. Show IPv6. Show IPv6 interface brief. Look at this. Still, it has not received. What may be the problem? It should have received by now. IPv6 unique is routing I have typed, and B should have received the address by now, but I did not. I'll do one thing. I'll just shut down and no shut once. Shut down this port once, and then I'll bring it up. Show IPv6 interface brief. I'm expecting an address here automatically coming, starting with beef. It will not take this long. Something is broken. I'll do one thing. I'll go here and put again this command. IPv6 unicast routing. Boom. IPv6 unicast. Boom. It is really surprising me. It won't take this long. I'll do one thing on RC. I'll refresh the interface. G000. Shut down. Bow. And shut. Bow. Here I have assigned this address. I don't see. Won't take this long. It's not working in packet tracer. Okay, what I'll do is, instead of wasting time like this, I'm going to quickly do and show you in the real operating system using GNS3. I'll only do this portion, okay? This portion. I'll do it only this portion. routers. As I said, I'll be having an address ::2 / 64. And here it's going to be odd routers. Now on router 1, interface F00, you see, no chat, I say IPv6 address, auto configure. Show IPv6 interface brief. You can see F00 on top with only a link local address as of now. But after going to router 2, interface F00, IPv6 address beef ::2 / 64, and after I say no shutdown, do you expect an address? No. Even now the address won't come because we have not enabled the IPv6 unicast routing. We have not enabled IPv6. So now I am going to debug and show you a few things. Debug IPv6. I have a lot of things to show you here. I'm going to say packets. Okay, now you see what happens. When I say IPv6 unicast routing, you will find the treasures on R1. See? Now router 1 says, I'm going to use this address. Is there anyone to object? Locally, I'm going to use this address. How router 1 knows that I should use BEEF? Because it was told to router 1 by router 2, which this debug did not capture. So now if you check, let me stop the debug. UAll is the command to stop the debug. And now if I check show IPv6 interface brief, you will find one address starting with beef. Pa-bow! And if you want, you can ping from here. It pings. And you can also ping from here, router 2. BEEF ::2. Boom. Did you understand auto address configuration? On router 1, we did not provide any address. It is automatically learned through the advertisement coming from router 2. So there is no need for DHCP here in auto address configuration.